All right, so we're going to actually start a little bit out of order for Chapter 8, Part 2.
Part 2.
Chapter 8, Part 1, we talked about a lot of multiplying and simplifying. And then in Chapter 8, Part 2, what we're going to be doing is factoring. And you learned one way of factoring already in Chapter 8, Part 1. What was that?
Like a common.
Pulling out a greatest common factor was what you learned originally. So now you're going to go into even further factoring, but you're going to need to remember pulling out the greatest common factor throughout the whole chapter. So we're actually jumping ahead to Lesson 8.8, which is the last lesson of the chapter. It's called factoring by grouping, but you're going to learn a different way that is not grouping. You're going to learn to use the rectangle. It's a little bit easier than grouping, but it's doing the exact same thing. Okay? So when you go to do the homework tonight, do not look at the examples in the book. Look at the examples in your notes, unless you want to learn factoring by grouping. Otherwise, you can learn what to do when you see this with the rectangle, which you've already started using. So this is Lesson 8.8. It's called factoring by grouping. But what you're going to learn to recognize it as is that when you see 4 terms, you're going to use the rectangle. You're not going to use grouping. So whenever you see something that says factor by grouping, you're just going to know that as this is when I have 4 terms and I use the rectangle. Example 1 says factor 4n cubed plus 8n squared, subtracting 5n, subtracting 10. How many terms do you have here? 4. Okay, so every time I see 4 terms, I'm going to follow these steps. Tomorrow we're going to be talking about 3 terms, the trinomials. So you have to be really good at recognizing how many terms you have here. So when you see 4 terms, first thing you're always going to do, and this is going to be across the board, whole entire chapter, every time you go to factor, you're always going to look for a common factor first. Okay, are you always going to have a common factor?
No.
No, but you're going to look for it. And if you do, you're going to do exactly what you did in Chapter 8, Part 1, where you pull that greatest common factor out, everything that's left goes into the parentheses. Do you have a question? Okay. Now, because you have 4 terms, your second step is going to be to set up a rectangle. No diamond yet. Okay, as of tomorrow, you're going to learn about the diamond. So you set up your rectangle. Well, first thing you're going to do actually is look over here and say, okay, do I have a greatest common factor?
No.
So first, do I have a GCF?
No.
1, just 1, right? So no GCF, so you can move on. Second, you're going to set up the rectangle because you see 4 terms there. So when you go to set up your rectangle, remember you always need space at the top for numbers that go at the top of the rectangles also. So make sure you leave space for those. How many boxes do you have there in your rectangle? 4. How many terms do you have? So what do you think you're going to do? Put a term in each box of the rectangle. Notice this is already in standard form. Does everyone see that? It needs to be in standard form, and you want to put it into the rectangle in standard form, left to right, just like you read a book, and down. So left, right, and then next row, left, right. Okay, you just follow that order, like you would be reading a book. So 4n cubed goes in the first box. In it. Because we're doing the opposite of what we learned last time. Last time you were putting things on the outside and multiplying them to get what goes in. Now you have what goes in, you're going to be factoring to get what goes on the outside. So you're doing the exact opposite. So 4n cubed plus 8n squared, subtracting 5n, subtracting 10. Always make sure it's in standard form. Now you're just going to pull out your greatest common factors, like we did on that worksheet a while ago. So what is your greatest common factor between 8n squared and a negative 10? 2. Most likely a positive 2, right? But you're going to check it to make sure later. What is your greatest common factor between 4n cubed and a negative 5n? 1n, so n. What is your greatest common factor for 4n cubed and positive 8n squared?
4n squared.
A 4 and an n squared. Okay, JJ, just so you see right there, if you had put a 2 there, 2n squared times n would have given you 2n cubed, right? And if you don't multiply these and get what goes there, you know you didn't pull out your greatest factor. So you would have been able to fix it. Okay, and then what's your greatest common factor between a negative 5n and a negative 10? Negative 5. Okay, the reason that it's a negative is because they were both negative terms, so you pull that negative out. Now you go check. You make sure all your negatives are correct, all your greatest factors are correct. You have to check this every time. 2 reasons you have to check it. First reason, easy to make mistakes with your signs in there and your greatest common factors. Second reason, not every single polynomial is factorable. So you might have set this up and you might have pulled out your greatest common factors and you check it and it doesn't multiply back out to be this. If it doesn't multiply back out to be that, first thing you're going to look for is, did I make a mistake in pulling out my greatest common factor or my signs? If you didn't, then it means that this was not factorable. It can't be factored. Something like that. So you're always looking for that. That's why you check. So you check by multiplying them. What's 4n squared times n? 4n cubed. Are we right so far? Okay, what's 4n squared times 2? 8n squared. Are we right so far? What's n times a negative 5? Negative 5n. What's a negative 5 times 2? So did everything work out?
Yeah.
So then our answer is in pink right here. Those are our binomials that you would have had in Chapter 8, Part 1, that you would have multiplied to get that right there. See how that works? So your answer is 4n squared subtracting 5 times n plus 2. And if you were to take those and multiply them out, you should get that. Salute.
Oh, thanks.
Okay, you can put these in any order. The n plus 2 can go first, and the 4n subtracting 5 can go second. But we kind of follow in order that when you have your variable here with the higher exponent, that's typically the one that would be written first. Do you see that? So the n squared was written first before the n. And then if you had an n and an n, the one with the coefficient tends to be written first, if there is one. Okay, any questions about that? All right. Let's do one more example. Example 2. (12p to the 4th) plus 10p cubed subtracting 36p squared subtracting 30p. So what is your first step every time you go to factor? Look for a GCF. So first thing, do we have a GCF?
Yes.
And what is it?
2p.
2p, right? 12, 10, 36, and 32 comes out of all of those. And we have 1p in common. So 2p. So your first step in this case is going to do exactly what you did in Chapter 8, Part 1. Pulling out your greatest common factor, rewriting what's left in the parentheses. So 2p comes on the outside. And now I'm going to divide it back into each term to find what goes in the parentheses. Just like we did in Chapter 8, Part 1. We pulled out a common factor of 2p. It's in the front. We're going to divide it back into each term. So 2 goes into 12 how many times?
6p cubed.
6, and we have p cubed left. 2 goes into 10 how many times? 5.
5p
P squared left. Subtracting 2 goes into 36. 18 and 1p left. And then subtracting 2 goes into 30 how many times? 15 and how many p's? None, because it's there. How can you check that right there? Multiply it to each, distributing, and you should have that right there. Everyone agree? Okay. Sometimes these polynomials, the only thing you can do when you factor them is what we just did. Pull out a greatest common factor. And that is as factored as you can go, which is what you were dealing with in Chapter 8, Part 1. But now we're going to take it a step further. Whenever you pull a greatest common factor out, you have to check to see if what's left in the parentheses can be factored further. So in this case, we're looking at it and we're saying there's how many terms left in our parentheses? 4 terms. How do you factor 4 terms? Use a rectangle. So you're going to try it. Now, there are times when you're going to plug these 4 terms into your rectangle and you're going to pull out the factors like we did here, and they aren't going to multiply out correctly. If that's the case, then this is as factored as you can go. But if it does factor further, then you factor it further and you write a full answer down. So you're always going to check for that last step. Now, this 2p doesn't just go away. It's part of your final answer. So what I tend to do, because I will forget about that 2p by the time I go do all the other work, what I tend to do is I take that 2p and I go put it with my answer right now. So I already have it with my answer there. And that way I'm not going to forget about it later. This, we just decided, is 4 terms. So we're going to use a rectangle. So you set up your rectangle. Are the 4 terms in standard form already? Yes, so you get to just plug it in order. If it wasn't in standard form, put it in standard form. So now we have a 6p cubed, positive 5p squared, negative 18p, and a negative 15.
Can I go to the bathroom? I just chipped my tooth.
You what?
I chipped my tooth.
Do you need to go to the health office? Okay.
How did you like sing to get your face on the table?
All right. Greatest common factor right here. What is our greatest common factor? 5. Positive 5. What is our greatest common factor right here?
3p.
6p.
Yeah, and if you had pulled out a 3p, that's okay because you'll catch it later if you're checking. So always check. 6p, greatest common factor here. P squared. JJ. No. So if you had pulled a 3 out here and a 1 here, notice it wouldn't multiply to be 6. Okay. And then what is your greatest common factor here? Negative 3, right? And now you check it. 6p times p squared is 6p to the third cubed. P squared times 5, 5p squared. 6p times a negative 3, negative 18p. Negative 3 times 5, negative 15. Did they all match up?
Yeah.
Okay. So now you have your 2p already there as part of your answer. And then you just write your new answers. P squared minus 3 times 6p plus 5 right next to it. And that is your final answer.
Would you ever be able to skip the GCF part and then just go straight to the rectangle?
No, you always want to pull the GCF out first. You'll find sometimes if you have a GCF that you left in there, that these won't work out right. It won't balance out correctly.
Why wouldn't the first one be the answer? 2p and 6p.
Right here, because this isn't factored completely. So all you did at this point was pull out the greatest common factor, but then it was able to be factored even further. Some of them, that is the answer, because you just get stuck there, you can't go any further. But you always check to see if it can go further. It's kind of like when you were multiplying out your exponents. If you had a 7 times 5 left, you needed to actually multiply them together. Same idea where it needs to be completely done. As simple as possible in this sense, factored. Yes, sir?
You know how you said that you can't skip the GCF? Well, when you get to, don't you still find a GCF in your answer and then take the GCF out of that?
That's what you would have to do. So it'd be further after, and you'd be pulling it out of both of these, and it can get a little bit confusing. So it's easier just to always check for it first, have it gone. And sometimes it's going to also change as we get into more factoring. You're going to see it's going to change other things too. When we get to the differences of squares, when we get to the trinomials, there's a lot of things where you have to get that out of there first. Miranda.
How can you tell when you have to factor it more?
You always try it. So I had 4 terms here. So because I had 4 terms, I'm going to try the rectangle. If I had plugged them into the rectangle and then I couldn't pull out factors that multiplied back to be that, then I would know that that was where I would stop. That's my answer. But you always try it. Diana.
So, are you always going to have 4 terms?
No.
Are there going to be times that...
You're going to have 3 terms tomorrow.
So, if you don't have to do it rectangle?
With 3 terms, you're going to do something different, which we'll learn tomorrow. But every time you see 4 terms, you want to go straight to greatest common factor, if there is one, then rectangle. Okay?
How do you check your answer if it's already like simplified there?
Right here. So what would you get if you were to multiply these 2 binomials together? What should you get?
6p to the 4th cube.
You should get this, right? If you were to take these and multiply them out, you should get that. Then what would you do to get up to here? Distribute that greatest common factor. So it's like a double check. I multiply these to see if I get that. Then I distribute that to see if I get to that. Kirsten? Yes.
Does it matter what order you put, like p squared minus 3 and 6? Does it matter if that one's first?
It really doesn't matter. This should always be first. And then the general rule is the highest exponent right there would go first. Any others? Any other questions? No? Okay, so we're going to add some stuff to the left side of our notes. Okay, when you have the rectangle, we're just going to write this in so you have it today if you need it, or later when you're studying if you forget. You're going to write one term in each square, or however you want to say that, and make sure that the equation was in standard form, or the expression, sorry. And then, like we've been practicing for a while, you're going to pull out the GCF. It has to be the GCF from each row. You need to watch positives and negatives. Really watch those positives and negatives. And then how do you check your work as you're going? Multiply it back out, right? Check by multiplying. Okay, every year I have a few students who think that once they do all that work, they actually have to go multiply it out to get their final answer. But if you go multiply it back out to get a final answer, you have the original expression, right? So this is your answer. Multiplying it back out is to check that answer. And I have a couple hints I'm going to give you with the negatives right now that you can start to get used to seeing. It's not going to be the case every single time. You just have to be really careful with the negatives. Typically, what you're going to find is that the first term right here isn't negative. Or if it is, what you're going to find is that there are a lot of negatives and you can pull a negative factor out. Even if it's a -1, you can pull that factor out. Sometimes you'll see that. And as we come across these, we'll talk about them more. But these are the general patterns that you're going to see in the rectangles most of the time. So these are some negative factor hints. When you see a rectangle, and this was in both of your examples, where the negatives are lined up like that, what is this term up here going to be most of the time? Positive. And what is this term right here going to be? Negative. Okay, that's a general pattern that you're going to see. Same thing if both of these were negative, then the negative would pull out in the front there. So whenever they're lined up, the negative gets pulled out with them. So same way, if we had it like this, if there was a negative and a negative there, what's this going to be? Negative. And what's this going to be? Positive. Because if you notice, negative times positive is negative right there. And this will be positive because negative times positive is negative. So this is a general pattern that you're going to see. Like I said, they're not all going to follow these, but when you see that, you should know right away that's the way it's going to work. And then the other one that you're going to see a lot is the diagonal, where you have negatives right here with these two terms, and then a positive here. How are you going to end up with negatives here, but then get to positive on that last term? Negative times negative is positive. So when you see that diagonal pattern, both of these are going to be negative. Because then you get positive times negative there, positive times negative there, negative times negative there. Okay, so those are the three general patterns you're going to see. When one doesn't fit that pattern, apply the rules you know about positives and negatives to it and make it work with pulling out the negatives wherever you need to.